Hello, Alexei. I'm fine, and you? Okay, so today we will solve another array problem that called New Year Chaos. This time looks like it will be medium level problem. Yeah, yes. And also we have like another medium level and hard level problem. So next streams will be interesting. And this one should be. So let's see what we have here. I will not read it out loud, so please set pause and read by yourself. So we have a queue of people. The people stand one after each other, and every person can bribe another person. So bribe means pay some money to get his place, so to change places with him. And we got array of numbers with that represent the persons in queue. And yes, it's initial order. So initial order, everyone stay like in the order. But if they change place, they can end up with like 2, 1, 5, 3, 4. And our task is to count how many minimum bribes was happen. So for example, in this case, we have the first bribe that 5 bribe 4 and go to his position, then he bribe third one, go to his position, and second bribe first one. So finally we have state 2, 1, 5, 3, 4 after all operation. So we have 1, 2, 3 operations. So we will need to print 3 in this case. No person can bribe more than 2 person. Okay. Okay, it's from the condition. Print to chaotic if state is invalid. So if we got wrong data, then we need to write to chaotic. Okay. Every person can do operation maximum of 2 times. So for example, the 5th person maximum can go to 3rd position. Maximum. He will not able to go further since he cannot bribe anyone. Let's think how we can apply it. Generally, like any algorithm is possible to use somewhere. the easiest the easiest appliance is some kind of games, and like from games it's generally possible to apply to anything that happens in life. But it's a bit hard to find a real life example like from the scratch, like why we need to count Like why it's matter at all to something. But it often happens that something change position and have some limitations, and it required to calculate it by some way, like how many times it happened to calculate cost of something and so on. So I'm not sure that I will able to provide example right now, but maybe a bit later something will come to my mind. So we have a limitation of 100,000 people in queue. And also we got multiple queues, not just one. So for example, we got 2 queues and we will need to answer for both of them. But I presume anyway we will complete code for just one. Yeah. So we will make a code for just one, and like for other ones nothing is changed. Like it doesn't matter how many of queues we need to solve, since it's the same. So how you think we can solve this task? No, we will got only one result, like 2, 1, 5, 3, 4, like the end one. It was just illustration of the process, how they come to this position. Yes, first one is second. Yes, yes. Yep. Yes. Okay, how we will do this? Okay, so we will compare 2 and 1, right? And what we will see from here? Okay, what will happen next? For example, you will compare 1 and 2. Okay. Um, First of all, the person can bribe only the person who in front of him, not like not everyone don't want to go back, everyone want to go forward. And maximum amount of bribes is 2. So if we see the greater number like in front, that means that he had bribe for some amount of times, right? Uh, yes, yes, yes. So it's the same with the 2. So barely the programming features is the same that a general language, that any language, because there's like no big difference. We just will describe everything that you just had told. So we will start with that. And if anyone like ahead for more than 2 positions, then we need to print too chaotic, since like he was not able to do this. He doesn't have enough money for this. Okay, we have this method, minimum bribes. We have q. Let's create a variable, a counter. How many bribes we have? We will return this counter. And now we will go through the queue. So go through every element. And also we need an index of an element. Index is position. So this is number. Let's call it number. And this is position. But generally the position will start from 0, since all arrays start with 0, so it will be 0, 1, 2, 3, 4, and so on. So we will need to add the 1 to the position. We can modify it just for convenience. And now we will see if number lower than position, then there was a bribe. If number is not lower than position, that means that he was bribed by someone else. So we will need to see that the number, we need to check that the difference between them is not more than 2. So let's calculate difference. What we need to do is to divide number from position. So if we will have 5 and 3, we will have 5 minus 3, so we will have 2 here. Now we need to check if diff is higher than 2, then we can instantly end our function and return text to chaotic, since it's not possible. This position is chaotic, yeah. Since this position is impossible. Otherwise, and we can not write else, since we have a return statement here and it end everything anyway. So we will add this number to our counter. So I presume that this not include all possible cases for the queue. So we write some super simple stupid algorithm that just count this difference. We can try now this code and see what will happen. By some reason we doesn't write anything. So the thing here is not the real bug, but the problem is with prepared code that it doesn't print result. So we just need to modify initial code to print output. So we just return all result, but initial code doesn't print it. So we want to print the result itself. So I doesn't count this as an error. So one of cases was solved properly, and two test cases was not solved. Let's start with the one that was solved properly. So we have one queue of 8 persons. 1, 2, 5, 3, 4, 7, 8, 6. Yeah, it looks like the initial one, but a bit modified. So the 5 one bribed 2 times, then 7 one and 8 one also had bribed by 1 time each of them. And we got a result of 4, so everything fine in this case. There is no problem and our algorithm work well. Let's see what else we have. But generally on the stream it will be no difference since we have code for full screen anyway. Yeah, so for me it's easier to navigate like this since I understand what is on screen. So let's go to another example. We have input of 2 of them, and it was expect to get 2 chaotic in second case. So the first case we solved properly. Like our output was 3, 4, and expected was 3 and 2 chaotic. So we need to explore the second case. I think it was mentioned here. Yes, it's our initial case. And let's try to understand what is wrong. So the problem here with the number 5, that goes for like a lot of position. He go from the 5th position to 2nd position, so he bribed 3 times, right? So it looks like by some reason our condition doesn't work well. Yeah, I got it, because we return result not from the function itself, but just from the cycle. So we need to rewrite the cycle to simple one or replace it with something else, but generally let's just rewrite it with a simple cycle. Instead of using for each, we will use just for. So the code itself is fine. The code itself is fine. The only thing that we will need to do is to modify it a bit to have our number and position. So the number, it's qi. So we took i's element from the queue and got this number. So this code will be the same, except the part when we make a return from the function, we return from minimum bribes and not from the cycle. So our code was fine for this part, or no. Maybe it was not. Okay, let's explore what is the problem. So since the first part was calculated properly, then I think we need to print this div and see what we have here. Yeah, it will be a bit hard to print since let's do it like this. Since other values will also print to the same output. So it's just a string. So I just print it here just to see what is my output, what is my current output. So when we go through our case, we have, by some reason, 2, 1, and 1 instead of 3, 1, and 1, right? 5 minus 2. So, like, what is the reason? What is the problem here? So if we okay, maybe it's possible. By some reason, we in our div we have number 2. Let's add to another number, so it will be position and the number itself, just to see what is the problem. So we have 3 and 1. Okay. Why we have 3 and 1? But I increase the position number, no? Yes, position is I plus 1. And 1 second. Second is number 1. We have 2. Yep. So we have a problem with check number 5 in the second example. So the 5 was gone from the 5th position to the 2nd position. And I want to compare this number 5 with the position number 2. By some reason, it works not properly, and either the wrong numbers disappear, either maybe the problem with this one that we add to our position and it like calculates something wrong. So I just try to understand what number looks strange to me and try to explore like problem with them. By some reason, here we maybe I need to add additional information. I will add information like number and position here. Number and position. And we'll add another symbol like 3 equals. I add 3 equals, just it doesn't matter what to add here. So we will take a look at the last one from here. So we compare number 2 with 1, right? Where is example? I lost an example. Yes, we have number 2 in queue. We compare it with 1. Like it should be changed by 1. Everything is fine. We compare. But if we compare 2 with 1, then it also should add 1, right? Why we doesn't have an arrow here? So we have a number, we have a position. If number lower than position, lower, yes, or no, it should be higher. Yeah, it will be super stupid if no. Oh, sorry. Okay. Let me just think from the start what is going wrong. We go through our queue one by one element. Our position in queue, like that represent our numbers, since we start with 1. We just add 1 to our element in array. The number that the person has on his cloth is taken properly, so there is no error. And if the number, for example, 2 and position is 1, then we need to check that number is greater than position. And we need to divide the position from number and not opposite. So let me just check this. Okay, now we have 2 cases that solve it properly. Generally, the most problem that can happen on interview is when you make a mistake like this, and it could took a lot of time to find it, because it's just like simple mistake that you compare the wrong things, and you should be very careful with such things. I hope like on next videos I will be more careful and will try to move a bit slowly in this case and don't try to rush some simple solution that I think that is simple. So let's see what we have in the wrong case. Now, so our output is 2 chaotic and 6, but expected one 2 chaotic and 7. So it means that originally it have 1 more bribe than it was that we had not calculated by some reason. Let's see what we have here. So we have this queue. I will add it here just to go through our code and think what has happened. So let's just count by ourselves how many bribes is here by our algorithm. So 1 1 0, 2 2 0, 5 3, there should be 2 bribes. 3 is go only backward, so it's 0. 7 and 5, there should be 2. This is 6 position and 8, there should be 2 of them. And both of this goes only backwards. But the thing here is that 6 is here and 4 here. So looks like person number 6 had bribe person number 4. So we doesn't count this situation when one person is ahead of another one. It like doesn't matter that he lost a lot of positions, but he's still ahead of the 4th one. So let's think when we can calculate this and how we can calculate this. Generally, we can go through all the numbers from I just have thought how we can like easily solve this task, but it will be not algorithmic optimal one solution. We can start with the first number and go through array, finding all the number that lower than our one, and count them, and just compare as we do. So if it's more than 2, then it's too chaotic. If it's less or equal to 2, we will add them. Let's go with this approach first, since it looks very simple for me, and it should be errorless. So it's easier solution. We have some algorithm, but it doesn't count these situations, and I'm not sure how easily to count them like faster than we do it right now. So the main thing that you should do with any task is to solve it like for our cases, and to make it optimal is another task, additional one. So let's go through our, I will start with the same code. So I will just leave it commented. Maybe we will return to this later. Maybe I can just, 1 second. I will move it here and we'll leave only cycle commented. Okay. So for every element we will get current number, and then we will go through array again. So we have our difference initially of 0. We will go from k equal I plus 1 to the last element. So for every person we go through like all array and find all the values for that have lower number than for this person. So we make additional cycle inside, and if our number is greater than number that is back to us, then we will increase our diff by 1. And after this, we will do like this. If the diff is greater than 2, then it's too chaotic. If it's not, then we just add the diff to our count. So let's run our code and see how it will work. Yay! So it works, at least for these cases. Let's run for other cases, and possibly it will not work for the cases where there's a lot of data, since the algorithm is not optimal one. So it was terminated due timeout, what means that our algorithm was slow to solve the task. But generally, we achieved 22 points. So we got some score. So the task is solved, but the algorithm is slow, so we doesn't get the highest score. We will need to optimize this algorithm right now, but let's start with calculating space complexity and time complexity to understand what we can do with this. We will start with space complexity, and then we'll go with time complexity. Let me move this code out of here for now. So space complexity means that how memory change depends on the incoming variables. We assign only one integer, so we don't have any data structures that aggregate some data. So we have space complexity 01. For time complexity, we go through all elements, and then we go through all elements one more time. So we have time complexity of n square. All other operations inside doesn't affect any data structures, doesn't change some complicated things, so everything is inside is just 1. So we have n square. So we should move from n square to something like n, or at least n log n. So we want to move to n log n, or just n. That will be good for us. So it should be solved somehow with just one way go through our array. Let's think. I presume that with this will also increase by something like 2n. Let me just set the signs here. It's just assumptions. Generally it happened like this. So to go through array one time, what data we can store? Let's think. Even someone is on his let's observe some cases. The interesting thing that some cases are locked, and you need to use some hackers to unlock, and you earn hackers by solving tasks. So you have limited amount of test cases, and you can also write your own test case if you want to test your data. For testing, I presume that we will have some additional lesson to learn how to test. So we need to go through array one time. For example, if number 1 is on proper position, then we can just ignore this number. We can try with this small optimization. with just instead of making cycle, we will make a cycle only if number not equal to I plus 1. So if number is not in position, this will not change an algorithm complexity, but I just want to take a look. Okay, it doesn't work at all. Doesn't work at all. Okay, this was bad idea. I just want to try, like, maybe, no, but no, it doesn't work. Okay. Even it's on his own position, there's possibly that he ahead of some other ones. Maybe we can just try to sort an array. Yes, right now it looks like obvious. Yeah, how I was not thought about it from the start. So, it's looks like an sorting algorithm. So, like, we need to move from this position to this position and just count steps. Like, it was super obvious. So it's just simple sorting algorithm for array to like make everything in order and count how many time we had change places of like any items. Sorting algorithms have complexity of n log n, so most probably we will not able to solve it with on, but maybe we will. It need to like think a bit about this later, since there is some constraints, like every item cannot go for more than like 2 steps. So we can try to go with some simple sorting algorithm, and I didn't remember a lot of them, like to write it from scratch. But maybe the simplest one, that called bubble algorithm, will work here, since we generally need to move any element for maximum of 2 times. So we can, let me just think, will it work here or not? If we will have this thing at the end with bubble sorted, like bubbles in some drink or something like this that just come from the bottom to top. So with bubble algorithm, we will start with every element, and we will exchange position between 2 of elements with each other if they are different, and we will repeat this until there will be like no changes. So we'll start with the number 2, and we'll compare with number 1. They are different, like the 2 is greater than 1, so we will exchange them 1 time, and we will go back to this position. Here we have 1, 2, 5, 3. So we will able to exchange 5 and 3. And we will go to previous step. Now we have 1, 2, 3, 5, 4. And again, we go to next element and exchange 5 with 4. And like everything is fine. So for this case, this solution should work properly, and looks like generally for exactly this case, we will have just complexity of n, but let's see what we have like in other more complicated cases. So for example, our second case was 25134. So we'll have here on the next step, like 2 is not possible to exchange with 5 since it's lower. We'll have like this one and like this one. So the one is just came up for 2 times. Then we will exchange 5. Then we will exchange again. And we count how many times we move every one of this. So we put 1 2 times. Then we start to exchange the number 5. No. Yes. No, we start to exchange number 3. So 3 move to the left 1 time. Then 4 move to the left again 1 time. And we come to this position, but we should get the result of 2 chaotic, since 5 had moved 3 times, right? So then in this case, instead of moving, maybe we will need additional data structure to count how many times each of person had moved. So we will able to count that 5 had moved not 2 but 3 times. Yes, so in this case for every number we will have additional structure that will consume additional memory. I presume that is possible to do without this, but generally we can start with this option. For how long? We already stream for 47 minutes, so if I will get this task in interview, I will fail this time. Do you want we continue tomorrow, or we will solve it today? I think no. Okay, so we will continue with implementing the sorting algorithm with counting all of this, like on next video. Since today we failed, it happens sometimes, like don't worry. Just next time we will be more clear and we will recognize such simple things as sorting, like from the first look, and not just with starting some strange algorithm and just go faster and write code. We need to think more, and only after this writing code. Okay, thank you for today talks, and have a nice day.